So we have x plus 3 times x plus 8 equals x. We have to have 0 on one side. We have to distribute, which is x squared, plus 8x plus 3x, which is 11x, and plus 24. Then we have x squared plus 10x plus 24 equals 0. And then we have x plus 6 and x plus 4. And we get x equals -6 and x equals -4. What do you think was the problem with this part D? What do you think was, is this okay? Perfect. Next question. Anything you want? 1C. So 11x squared minus 9x minus 1 equals 0. So x equals -b plus or minus. If you write -81, I cannot give points. Because this is what I mentioned in class several times. Under the square root, the first portion, at the end, the quantity under the square root could be negative. But if you start with -81, I can give credit. Because -9 squared is not -81. So it's +81 minus 4ac, which is +44 over 22. So this becomes x equals 9 plus or minus the square root of 125 over 22, or x equals 9 plus or minus 5, the square root of 5 over 22. I needed to see this and then the approximation only if you wanted to. Anything else from page 1?
1B.
I'm sorry?
1B.
1b? Okay. So in 1b we have x squared plus 8x plus 18 equals 0. We're asked to use the completing the square, 8. 8 divided by 2 is 4. We square 4, we get 16. So this is x squared plus 8x plus 16 equals -18 plus 16. Have to add 16 to both sides, and I have to move 18. Or someone did something very nice. That person split 18 into 16 and 2 and only moved 2 to the other side because 16 should stay on that side, on the left. So then it was very nice. So equals -2. And now I have to take the square root. X plus 4 equals plus or minus I, the square root of 2. You can no longer leave the square root of -2 as the square root of -2 because we know what it means. So then this is x equals -4 plus or minus I, the square root of 2. Any questions here? Is this okay? Is this okay? Okay. Next problem. Anything else from page 1? Okay, moving to page 2. I cannot give full credit if you don't show me how you determine the vertex. So if you just write -1, 4, I can't give full credit. You have to show me -b over 2a and how you determined it, because if you just plugged it in the calculator and if you found the maximum like that, I can give credit. Sure. So we have f of x equals -x squared minus 2x plus 3. Yes.
Can I see the paper you just took off?
So yes. So let's wait. Let's wait till you finish. Yes. Yeah. Just finish it. So I'll wait, and then we can continue. That's fine. Because I want you to pay attention on, when we work on the second one. Is this okay?
Yes.
So for this function, we have, first of all, the shape is a maximum. And then I have to find negative b over 2a, which is negative b, over 2 times a. So all this gives us a negative 1. So you have to be very careful, because I think I saw a negative 1 in the denominator instead of a negative 2. So then the vertex has negative 1 as the x-coordinate. In order to find the y-coordinate, I have to plug it in. So f of negative 1 equals negative 1 plus 2 plus 3, 5 minus 1 is 4. So that's how I have to show this part of the work to find that gave us the vertex. Now the x-intercepts, I know they exist because the function has a maximum, and the maximum value is positive. If the maximum value were negative, then the function would have not touched the x-axis. Okay? So the x-intercepts when y is 0. Negative x squared minus 2x plus 3 equals 0. I saw some of you use the quadratic formula with the negative leading coefficient. It's risky. It's fine, but it's risky, so careful on that. I will never do that myself, but it's acceptable, but it's risky. Be careful. So x squared plus 2x minus 3 equals 0. So then x plus 3 and x minus 1, everyone did that correctly. So x equals negative 3, so negative 3, 0, and x equals 1 or 1, 0. Are we okay with that? Is this okay? So we have the maximum, we have the vertex, and we have the x-intercepts. Is that okay, everyone? Yes? Yes? Okay, so now the y-intercept, all I have to do is find f of 0, which is 3. So 0, 3. And now the axis of symmetry and the max. What is the axis of symmetry? Perfect. And the max value is 4. Since I know the max value is 4, I already have the range even before I graph the function. Very good. Excellent. Okay? So now when we graph the function, we always start with the vertex, which is negative 1, 4. Then we graph the axis of symmetry, then the x and y intercepts, and then the y-intercept. And here's the graph. Of f of x equals negative x squared minus 2x plus 3. Is number 3 okay? Which one?
Right?
Yes. Is this clear? Is number 2 okay? Yes? So we have x, negative x plus 3, x plus 4 greater than 0. And we have x as the variable in the problem. This is not the only method. I saw other methods. Very good. Well done. Negative x plus 3 and x plus 4. And since I don't have enough room here, I'm going to say just the product. X is the variable in the problem. But now this x has 0, this one has 3, and this one has negative 4. These are the zeros of those factors. X is 0 when x is 0. Negative x plus 3 is 0 when x is 3. And x plus 4 is 0 when x is negative 4. So negative 4, 0, and 3 is the correct order of solutions. Agreed? Yes? So then there is a 0 for x, there is a 0 for 3, and there is a 0 for -4. And the product is 0 for any of those. Two of those look like this, from negative to positive, and one of them looks like this, from positive to negative. This one is the one that looks from positive because the leading coefficient is negative. So this one will be this. The other two will be this. Or the other method that's one or two students worked with, that's fine. That's a different way. On this interval, 2 negatives. On this interval, 1 negative, no negatives, and 1 negative. So we want positive. So positive is here and here, not 0. So negative infinity to -4 and union 0 to 3. And that's x. Is this okay? Okay, do we have to look at number 4?
4B.
4b. According to this model, in what year will the passenger traffic at Atlanta, will reach 99,000? 99,000 equals -32x squared plus 1733x plus 76,362. This is a quadratic equation. We have to set it equal to 0. I move all terms to the other side, and I get 32x squared minus 1733x. And how much is 99,000 minus 76,362? As you see, I'm lazy tonight. I got 22638. I will use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2 times a. I will put this in the graphing calculator, and can anyone give us the solution so I don't have to put it in? X was 22? Okay, and the other solution, x equal, I know it's unacceptable, but what?
32.16.
How much?
32.16.
Okay. So I thought it was negative. So because we don't know whether 32 years from now the model is still true, we will accept the first one. If you wrote both, I would have said, okay, assuming that the model still holds, maybe 32 years from now, the same thing will happen. But for now, I would say the 22 is the best option. Anything else in problem 4?
4C.
All you have to do is find negative b over 2a. Because that's a problem on the vertex, a question on the vertex. So negative b over 2a, negative b 1733 over 2 times a, which is negative 64. Can anyone give us this number?
27.8.
27.8? Okay, 0.8. And then I have to find the maximum by finding f of 27.08. Can anyone give us this number? Let me write it first, like negative 32 times 27.08 squared plus 1733 times 27.08 and plus 76,362. How much was the maximum? 99,825. What about problem 5? Do we need anything in problem 5?
Yes.
Okay. So the function such and such in feet represents the height of a ball thrown upward. Find when the ball will reach the ground. Reaching the ground means the height is 0. So negative 16t squared plus 16t plus 96 equals 0.
Question.
Yes.
4C. Where it has 2 pluses, so it's plus 1733 times 27.11 again, right?
You mean this one?
Yep.
Yes, that was the function. Negative 32x squared times 1733 times x. Yes. So in the second one, I will divide both sides, hopefully, by negative 16. And this is t squared minus t and minus 6 equals 0. And then when I factor into t minus 3 and t plus 2, I get two different solutions for time. 3 seconds and negative 2 seconds, which is not acceptable. So the ball hits the ground in 3 seconds. Anything else on page 4? Any questions on page 4? Which one?
6B.
You said 6 to 8?
6B.
6B. Okay, very good. So for 6B, we did this problem in class last time. It should be in your notes, but it's okay. Let's do it again. I would have used the substitution. Some of you didn't, which is okay. But what I saw, I didn't like. And I saw this. Why is that not acceptable? How come that this piece does not equal this piece? What is wrong? Order of operations. I have to square first and then multiply. So it's okay. We learn from our mistakes. We always hope. I always hope that I learn from my mistakes, talking about myself. So please remember, you cannot distribute before you square. So careful with that. So what I would have done this. I would have denoted 4x minus 3 by t. And then I would have had this. Factor this completely. Get two solutions for t. And then solve. So I just wanted for a second, as I'm also checking my memory. I remember doing this problem in class. Am I correct? You can say I'm not. It's okay. Oh no, I did not post the lecture notes. Sorry, I can show it. I have to upload it first. Okay, so let's not waste time for that. I will do that before I leave tonight. Okay, so we are looking for two numbers whose product is negative 10 and whose sum is negative 9. And those numbers will be negative 10 and positive 1. So therefore, we have 2t squared minus 10t plus t minus 5 equals 0. So this is 2t, t minus 5, and t minus 5 equals 0. And we have positive 1. So then this is t minus 5 and 2t plus 1. And we have two options, t equals 5 and t equals negative 1/2. From here, I have to set this is a new equation, which is 4x minus 3 equals 5. And this is a new equation, which is 4x minus 3 equals negative 1/2. From here, I get 4x equals 8, which is x equals 2. And from here, I get 4x equals 3 minus 1/2. 4x, 6 minus 1, 5/2. So x equals 5/8. Any questions? Any questions? Any questions? Number 7. Is number 7 clear? Sure. The discriminant is positive to real solutions. The discriminant is negative to imaginary solutions. The discriminant is 0, 1, real solution. So one more time, the discriminant positive.
Can you write that down?
Sure. B squared minus 4AC greater than 0, 2 real solutions. B squared minus 4AC equals 0, 1 real solution. And B squared minus 4AC less than 0, 2 imaginary. Is that okay? Yes? Yes? Is that okay?
And this is
Say it again.
6A.
Oh, we want to do 6A? Okay, very good. So in 6A, we have x to the 4th minus 13x squared plus 36 equals 0. We observe the same thing, that if I denote this by t, then x to the 4th will be t squared. So then t squared minus t plus 36 equals 0. Remember, 4 solutions. We are expecting 4 solutions because the degree is 4. So this is t plus 4. Did I? Oh, I right. Okay. So this is t minus 4 and t minus 9. It's 13 here, 13t. So t must equal 4 or 9. But this equation is really x squared equals 4, and this one is really x squared equals 9. Remember, when we take square roots, we have to write plus or minus. So x equals plus or minus 2, and x equals plus or minus 3. When you start solving an equation, always think in terms of, okay, how many solutions I expect? And I'm hoping that that will trigger your memory and say, oh, I forgot to put plus or minus. That's why. Any questions? Is there anything else? Is there anything else? Do we need help on the extra credit? Okay. So for the extra credit, we have the two numbers differ by 8. And we're asked to look at their product and see and find their minimum or maximum. So from here I have x equals y plus 8, and I will replace it in the product. So p of x will be x, p of y will be x, which is y plus 8, multiplied by y, so it's y squared plus 8y. Again, I have to find negative b over 2a, which is negative a divided by 2, which is negative 4. If y is negative 4, then x is, so y equals negative 4, then x is 4. And the minimum product is negative 16. So the minimum product is negative 16, and the numbers are x equals 4 and y equals negative 4. I needed it because I didn't have another one. Good. Any questions? Is this okay? Any questions? Yes, Becky, go ahead, please.
3 1 squared x y minus 4 equals 0. Solve this line.
So which, can you repeat that?
3y squared plus 6y minus 4 equals 0. Solve this by completing this line.
Yes, in that case I have to divide everything by 3. It's mandatory. Y squared plus 2y minus 4 divided by 3 equals 0. Remember, we cannot complete the square if the leading coefficient is not 1. Even if I have to, by force, divide both sides by 3, I have no choice. So now the middle coefficient is 2. When I divide 2 by 2, I get 1. When I square 1, I get 1. So this is the number that I have to add to both sides, and then this has to be moved to the other side. So then I have y squared plus 2y plus 1 equals 4/3 plus 1. Is this okay so far? Yes? Thank you. Is this okay? So now the left-hand side I have, it's y plus 1, everything squared. And the right-hand side is 7/3. However, I can't solve unless I remember that I have to apply now the square root. So then I have y plus 1 equals plus or minus the square root of 7 over the square root of 3, and I have to rationalize with the square root of 3 as we learned in chapter 10. So then y will be, I move 1, negative 1 plus or minus the square root of 21 over 3. Is this better? Any questions? Is there anything else you would like to go back to? Anything else you worked on? It is very important to keep up with the homework. Very important. You see how important it is. Okay. Can we start chapter 7? Before I forget, every Saturday between 12 and 2 p.m. I will be in this room. Except next Saturday because the school is closed. So this Saturday, not the following one, and then 2 more afterwards before the final exam. So 3 Saturdays in a row except next Saturday. So if you want to come in and review or work on problems or ask questions, please do so. Okay? So I will be here this Saturday from 12 to 2. Not next Saturday, but also I'll remind you next week, following 2 Saturdays after Thanksgiving. Okay? This Saturday, yes. The following Saturday for Thanksgiving, we're closed. No, yes, we do. But not Thursday. Yes. So I would like to meet and make that up somehow, assuming no. No. Mike said no.
What?
Okay. So 3 Saturdays, this Saturday, this week, and after Thanksgiving, the following 2 Saturdays. I'm sorry? What if I give you a piece of paper? I'm sure I have, but I don't want to. And I can give you one at the end of the class. But I don't want to wait, go through my stuff right now. But remind me at the end of the class, I'll give you one. Okay, so I would like to start chapter 7. And then we still have chapter 12 to look at. Only specific sections. Only a total of 5 sections in chapter 12. We are down to about 3 weeks left. So, like with chapter 6, we are going to go through this handout completely. And then when we finish, we're going to go to the book. So we're going to finish the chapter using this handout. And then we'll go back to the book and practice some more. Okay? This is the second application of factoring. Why is it the second application? Because the first application is solving equations. That was the first application. Now this is the second application, rational expressions. The entire chapter 7, without knowing factoring, it will be very difficult for us to go through this chapter. Yes? Yes, it's right in front of you. Is that? Right. Okay, so let's start with what a rational expression is. A rational expression is a ratio of 2 polynomials. Ratio of two polynomials. Ratio of two polynomials. And here are a few examples. 1 over x, 2x minus 4 over x minus 1, 1 minus x over 2x. This one is not a rational expression. This is a linear expression. It's 0.5x. So the point I'm making is if there is no ratio, it cannot be a rational. And also if it doesn't have x in the denominator, it's not a rational expression. Like this one. Has a ratio, but x no x in the denominator. So this is simply 0.5x. Simplifying rational expressions. Simplify only factors. We have seen this before, in which I specifically said, here, let me give you an example here. For example, if I have 2x plus 4 over x minus 1, I said this is unacceptable because x is not a factor and x is not a factor. So you cannot simplify this in any way, shape, or form. So that's why I put this note here. We can only simplify factors. If it's not a factor, you cannot simplify it. Now, what do we know about division by 0? And this is valid here when we have x in the denominator as well. Division by 0 is, say it again? Right, but what word do we like to use? We are very proud of this word. Okay. Nothing wrong with saying not possible. It's correct. But we like to say undefined. So then a rational expression is undefined when? Exactly. Its denominator is 0. So a rational expression is undefined when its denominator is 0 because division by 0 is undefined. Very good. Now, we're asked in the first set of examples, we're asked to simplify the following rational expressions. It says state restrictions on the variables. So I have to explain this before we go over those problems. So here it is. Is 2 over 2 1? Is 10 over 10 1? Do I have to state a restriction here? No. 2 is 2. 2 is not 0. 2 divided by 2 is 1. 10 divided by 10 is 1. 0 divided by 0 is not 1. So you have to wait till calculus for this. So do not ever say that 0 over 0 is 1. That's an indeterminate case, so we cannot discuss that. So my question is now, can I say that x over x is 1? There is, say it again? Exactly. If x does not equal 0. So x over x is 1 only if x is not 0, because we just discussed that 0 over 0 is not 1. So this is what we call, this is called a restriction on the variable. Meaning, x is restricted. It cannot be just anything. It can be anything except 0. So now here's another question. What about x plus 2 divided by x plus 2? Is this 1?
Yes.
If? Exactly. The denominator cannot be 0, not the variable, the entire denominator. The denominator is x plus 2. When x plus 2 is not 0, then that makes x not equal -2. So these are restrictions on the variable. So now we can come back and complete these 4 problems. Let's start with the top one. I've seen this before, right, in exponents. I can tell that x cannot be 0. I can tell that y cannot be 0 for the first problem because they are present in the denominator, and those are the factors x and y. And now I can continue by simplifying. I simplify 16 and 24 by 8. I take away an x from the top and an x from the bottom. It's too small. I have to copy it. So 16x squared y divided by 24xy cubed. I simplify 16 by 8 and I get 2. 24 by 8 and I get 3. I take away an x from the top with an x from the bottom. And I take away a y from the top with a y from the bottom. What is left at the top? 2 and x, nothing else. What is left at the bottom? In the bottom, 3y squared.
What did you divide by?
Which one?
16 and 24. What did
By
you-
8. 16 divided by 8 is 2. 24 divided by 8 is 3. But of course, this is true only if x is not 0 and y is not 0. Any questions? Okay, we're just practicing. 5 minus 2x over 2x minus 5. And then I'll do one more and then you'll do the last one, or vice versa. I'll do the last one and you'll do C. Remember from the previous chapter, chapter 6, we said everything has to be in descending order and no negative leading coefficient. So the bottom is fine, the top is not. So I will rearrange it into this. I will factor out -1. This is all from chapter 6. This is not new. But now, before I simplify, I have to state the restriction. It has to be written before I simplify, because after I simplify, it's gone. And I will not have anything to write. So what will be the restriction on x? What is the value of x that I can never have in this problem? No, because 2 times 0 minus 5 is -5. Yes, 5 over 2. So I have to write 2x minus 5 not equals 0, move 5 and divide by 2. Are you with me on this? Yes? Okay, so then what is the final answer? I always encourage you when you simplify, write 1, because you may think of 0, which is not the case. So then what is the simplified form of this expression, assuming x is never 5/2? Very good. So the answer is this. It includes the restriction. I caution you that your book does not do that, and it's wrong. We know x divided by x is not 1. Is 1 only if x is not 0, and so on and so forth. So here the correct answer is the simplified form is -1 only if x is not 5/2. Okay, I'll skip over C and you'll do C, but I'd like to show D. 3x to the third minus 12x divided by 6x to the third minus 24x squared and plus 24x. So here's what I would like to do, and you tell me yes or no. Okay? I'd like to do this. Simplify x cubed with x cubed, 3 with 6, I don't know, 12 with 24, and get a 2, and x with x, and I get, I don't know, what am I getting at the top? 1, and the bottom, blah, blah, blah. Can I do this?
No.
Of course not. Because I am not simplifying factors. 3 is not a factor here, unless I pull it out. 12 is not a factor here, unless, right? So this would be a terrible mistake. So then let me write the problem one more time. What will you tell me to do? Just walk me through this problem.
Factor out 3 from the top.
3x, very good. What is left in parentheses? Squared minus 4, very good. It's in descending order, it's a binomial. I have to pull out the greatest common factor as we discussed in chapter 6. And now the denominator.
Pull out 6x.
Very good. What is left in parentheses?
X squared.
Yes,
4x. Plus 4.
very good. Now I go back to the top. Don't simplify just yet. Wait till the end for a second. So what now? The top 3x, what else?
Factor x squared minus 4.
Very good. How?
X plus 2.
Perfect. Now I have 6x in the denominator, and what does x squared minus 4x plus 4 become? That's why I said that from the beginning, and we signed an agreement 3 months ago. It's in descending order and special product.
A minus b squared.
Good, which is?
X minus 2.
Very good. Let's check the middle term. Minus 2 times the first times the second, which is negative 4x. At this point, after I fully factor top and bottom, at this point, I'm ready to write restrictions. I cannot touch anything, I cannot simplify anything before I write restrictions. How many restrictions would you write? There are 3 factors, you're right, but not 6, right? So one restriction comes from x, the other one from x minus 2, and the other one from x minus 2, but they are the same. So 2 restrictions. From x, I get 0, and from x minus 2, I get 2. Now I'm free to simplify. I will simplify an x minus 2 with an x minus 2. I will simplify an x with an x and a 3 with 6. What is left at the top? Danielle, please ask. Go ahead. So 3 is divided by 3 and I get 1. 6 is divided by 3 and I get 2. X is divided by x and I get 1. And x is divided by x and I get 1. Then x minus 2 is divided by x minus 2 and I get 1. And x minus 2 squared divided by x minus 2, I cross out just the power. I take away 1 from here and 1 from here. What is left from the top? Very good. What is left from the denominator? 2 times x minus 2. So the correct answer is this. This whole rational expression simplifies to x plus 2 over 2 times x minus 2 only when and only if x is not 0 and x is not 2.
So why don't we have to say x doesn't equal negative 2?
Because the numerator can be 0. A rational expression is undefined when its denominator is 0. The numerator can be anything. We never have to restrict the numerator. The potential problem is the denominator. Is that okay? Good. Now, I would like you to work on a squared plus 7a minus 8 divided by a squared plus 6a minus 7.